Good morning, one and all. On behalf of Janata Education Society, Vivekananda Institute of Technology, and the Department of Computer Science and Engineering, my name is Lakshmikanta GC, Assistant Professor, Department of CSE. It's my privilege to welcome you all to a 3-day national webinar on software testing tools and its methodology. The students of the future will demand the learning support that is appropriate for their situation or context. Nothing more, nothing less. And they want it at the moment the need arises, not sooner, not later. Mobile devices will be a key technology to providing that learning support. Online learning like webinars becoming one of the cost-effective ways to educate the world's rapidly expanding workforce. First, I should be honored to welcome our management of Janata Education Society and Vivekananda Institute of Technology, as they provided us fully equipped with all the infrastructural facilities, free from pollution with general greenery and gorgeous campus. Owing to all these things, our department is hosting this online national webinar today. It's my privilege to welcome our beloved principal, Dr. Kumar Kenchegowda, who is always inspiring us to achieve more towards gaining knowledge and influencing all our staffs and students. I welcome you, sir. Our Vice Principal, Dr. D.V. Chandrasekhar, sir, who is constantly with us, guiding through in all the activities. I welcome you, sir. I'm sincerely grateful, and it's my ardent desire to welcome our beloved HOD, Dr. Vidya A., Professor and Head, Department of Computer Science and Engineering. I welcome you, ma'am.
Thank you.
I also extend my heartily welcome to all our today's speaker, Mr. Chandrasekhar PS, who is concurrently working as Project Manager in Foxconn India Developers Private Limited, Bangalore. Mr. Chandrasekhar BS, 15 plus years of IT industry experience, worked as developers, tester, test lead and project manager. He started his career with Satyam Computer Private Limited, Bangalore as software engineer for 2.5 years. Worked with Huawei Technologies India Private Limited, Bangalore as test engineer for 1.6 years. Worked with Nokia India R&D Private Limited, Bangalore as senior R&D test engineer for 7.3 years. Worked with Microsoft India R&D Private Limited, Bangalore as SDET test lead for 1.11 years. And now since December 2016, working with Foxconn India Developers Private Limited, Bangalore as project manager. Added to this, one patent approved and filed at Microsoft India R&D Private Limited, Bangalore. He owned ISTQB Foundation Certificate, Huawei Certified Test Engineer, Certified Project Management from IISc Bangalore. It's really proud and luck to have you today as speaker for our event. I welcome you, sir.
Thank you.
I extend my special welcome to my coordinator, Professor Chandrama R. I welcome you, ma'am.
Thank you, sir.
I also extend my welcome to all the participants who have registered with us today, and they are the part of our success in today's event. I welcome you all. Once again, I extend my heartily welcome to all the HODs of various departments, teaching and non-teaching staff of Department of Computer Science and Engineering. I welcome you all. Now, it's my ardent desire to invite our beloved HOD, Dr. Vidya A., to give few valuable words about today's national webinar. Ma'am, mute agide.
Thank you, Lakshmikant. Once again, I would like to welcome today's speaker, Mr. Chandrasekhar sir, for today's webinar. Thanks for accepting our invitation. Thank you, sir. I request all the participants to take active participation during this 3-day webinar, software testing tools and its methodologies. I wish them all the best and have a good day. Thank you all.
Thank you, ma'am. Thanks for your valuable words. Today, we are presenting software testing tools and its methodologies presented by Mr. Chandrasekhar BS. Just a little housekeeping before we get started. If you have any queries during the presentation, please type them into the online chatting box in your YouTube control panel. I will bring them up during the presentation, and we will also have time for questions at the end. Now, without further ado, we will turn the time over to Mr. Chandrasekhar BS.
Thank you, Lakshmikant, and all the other colleagues. Hello, everyone. Good morning to all online education team members and support team, everybody. My name is Chandrasekhar BS. Today, day one, software testing methodologies and test techniques will be discussed through this session. Agenda for today is why software testing is important and why we have to learn the methodologies, what are the best methodologies which we need to consider during the software development, and how many types are there in that, and what types of techniques that need to be applied when you select what kind of projects you are working on. So this is the agenda for today. So I will go one by one. So importance of software testing. Software testing plays a very crucial and important role in the advancement of software. So software testing methods, why software testing is necessary? Because we all humans are the one who develop the products, and we are the one who consumes the products. So all the human beings are not the same, because we have different sense organs and different way of thinking. So testing is important to, because one product cannot satisfy all the customer needs. So testing is important to find the critical issues which are not life-threatening and which are not hazard to the society. Software testing is necessary. We all make mistakes. Some of those mistakes are unimportant. That means we can ignore, but some of them are very dangerous and life-threatening. As I said, we need to check everything we produce before we think that it may go wrong. We all human, we know we make mistakes. In exams also, after we finish writing, we will do one more review or recheck. This is nothing but static testing in software terms we call. Okay, so we know every system has a bug, and in today's industry, every product needs innovation, creativity, so that they are in the market. So each product has its own competition, because if you take any product, they have their own competitors, and each product need to have their best quality, so that customers needs to come back for their product, not with the complaints or with the throwbacks on their faces. So customer feedbacks are important. So customer feedbacks collection process needs to be fast enough. So this leads to the lot of testing importance in the software development lifecycle, as well as in any manufacturing industries. As we catch many bugs in the early stage of the development lifecycle, we will try to make less loss to the companies, because one critical issue which is found in the end user hand makes a very bad impression in the market, and that will come back to the company in a huge way. So huge losses to the companies is very bad, and it will create a bad brand name to the companies. So the testing is, and finding the bugs at the early stages is very important. So testing is not only done at the software level or anywhere. Testings are done at the various industries at various levels, and they follow their own methodologies. But today what we are discussing is only related to software test methodologies. So as we know nowadays, COVID, they are also doing the trials. That is nothing but a kind of testing before it goes to the human and cures the disease. So these things may lead to testing an important and crucial role in the product development life cycle. As you know, disasters happen uh, by small mistakes. While we are launching in our Indian satellite, there was a fuel tank leak. So that was detected very earlier before the launch, and that was stopped. So that stoppage may incur the days which the engineers have put, but the business billions of dollars have been saved. Same thing, the plane crashes. We have black box, and they have their own system to track why the plane has crashed, and that things have been happening. So when you go to radioactive, nowadays the nuclear power plants have been implemented, and all these upcoming products require more quality with reliable softwares. So software without flaws or without crucial flaws is very important. So what is the advantages of testing? Software testing uses lot of confidence in the quality of the final product. It saves lot of time, effort, money for the organization that are developing and selling the products. Because once the product is tested, they can be sure that there will be no fault that would prove the fatal to them on the later stage or even for the business opportunities. This confirms that the application is able to operate in other different scenarios or different operating system or different web browsers correctly, and that will enhance the user experience and satisfactions. Lastly, all these things what we are doing will increase the money profit for the companies. So there are more maximum advantages of testing. So to have all these advantages, we need to have some kind of methods that to be followed in the industry. So from since 1980 or 1970, software development models have been coming up, and there was various improvements in them. So to start with software testing, we have two kinds of things. One is software testing methodologies, software testing techniques that are used under it. In software testing methodologies, one is sequential and incremental process. In software testing techniques, that is structured or called as white box. Black box is called as specification based testing. Again, I will go in details in the coming slides. Just to give the scenario, what I will be going through the slides. So in sequential, we have waterfall model, V model. In incremental, we have incremental model, agile model, which is currently very popular, and rapid application development model, which is even popular. And in from 2010 or 2012 onwards, nowadays, you know, the DevOps. This is the most tech buzzword in the industry. So why software testing methodologies? We need to have the best software testing methodologies that can be used. The end user products delivered with high quality customers should come back again and again. As I said earlier, the software methodologies, or we some calls as models, or the have various process or methods that being selected for the development of the project depending on the project goal or aim. There are many development lifecycle models that have been developed in order to achieve different objectives. The model specifies at the various stages of process and the order in which they are carried out. So selection of model is very important, and it impacts on the product lifecycle and testing lifecycle that is being carried out. It will be defined what when the plan to be tested. Influence of the regression testing and largely determines what test techniques to be used. I will be explaining those things techniques. Different companies of software application or product, they select the type of development model whichever suits for their needs or application. But the current buzzwords in the market is Agile methodology, DevOps, which are mostly used. I will walk through the waterfall model, which is very basic model, which was found in by Whitson Royce in 1970. This model has multiple stages of processes in a sequential manner. that flows progressively downwards. Like when the business, when a business analyst goes and meets the customer, he collects the customer requirements, and customer requirements are again break down into design models. The designs can be of architectures who involve in that, like high-level design, low-level designs, and based on this low-level design, the software development team involves in the implementation of coding, and the process continues. Once the coding is done, verification of the product is handed over to the testing team. When the product and the testing satisfies the specifications, then it goes to the operations team, that is the maintenance teams. So this is how every stages in the waterfall model is in sequential: requirement, design, implementation, then verification and maintenance. So this has been followed where there are small projects. So I will tell you the advantages and disadvantages of this model. Advantages of waterfall model: this is simple and very easy to understand and to use. So startup companies try to use this kind of water model to develop the prototypes for them. Easy to manage due to rigidity of the model, means the requirement is very clear and there is no change in the requirement. Then this model is very useful and they can use this model. And there is no overlap in the phase, like development cannot go back and ask for the change in the high level or low level designs, or maintenance cannot ask for more systems. Like this, there is no overlaps in the model, so the product process goes step by step downwards. So disadvantages, I said earlier, like application is at the in the last stage, the testing team will get, and it has been tested, and there is no chance to go back and change the requirements. But only thing is they can fix whatever the issues are there. There is a high amount of risk and uncertainty that we don't know how the product will behave at the customer end, because the requirements are freezed. And not a good model for the complex and object-oriented projects. Like object-oriented, we have class and inheritance and virtual inheritance. So it is not good to have this kind of waterfall models to there, and not suitable for the projects which are at high risk. So when to use this model? So the models is usable only when the requirements are very well known, clear and fixed. Product definition is stable. Technologies used are understood. Like we use only Windows 10 to develop this software, or Windows, if the Windows 10 upgrades to Windows 11, then this software will not work. So this is the flaw in the waterfall model. So expertise means all the requirements, high level and low level design, architects should be available to the projects all the time. So this is there, then we can use this model. So this project is only for the short time project goals. And there is an improvement happened in this model going forward, that is called as V model. This model can be called as verification and validation. V model is the extension of waterfall model, where the process of execution takes place in the sequential type that goes upwards and again it goes downwards, and a V shape. Like if you see the diagram, there is a direct association between the stages. When the business analyst goes and collect the business requirement, that is called as BRS. That acceptance testing, that the test team will start planning and they will start writing the test plans. When the system requirements or business requirements are broken down into system requirements, then the system testings are planned, like what kind of systems are needed, what kind of hardware, what kind of software needs to be used. And when again it is broken down into high level designs, system integration teams comes into picture, like what all systems are needed to continue with this. Low level, then the development teams comes into picture, and the test team will start writing the unit tests in the industry. And coding, same as unit testing, and the code starts. Again, this is where the huge documentation process is happening. Like when business requirements are collected, test plan is designed. For the test plan, for the next level, the SRS, then test specification is designed. High level design, then the test cases are written, test matrix are prepared. So each development life cycle is associated with testers team lifecycle. So documentation is more in this V model. So this is again, it's a sequential model. So this has advantages and disadvantages. The advantages, again, it is derived from waterfall model. It is easy to use. Testing activities like test plans, as I said, test designs, test happens in the associated phases. And the defect tracking will happen at their phases only. And a lot of communications happen here between the associated stages. They avoid the downfall fault defects. If any defects found in the high-level design, it's been discussed and test cases are written for that. If that feature is not specified, then they will modify. This kind of things are found at the high-level design, low-level design. So the test defects like bugs which are found at the last stage is very less in this V model. So again, this V model is very rigid and least flexible. For example, if you take a website with a login page and logout page, this is clear. But if the customer comes back with asking for show password or remember password, then this cannot be implemented because it has passed through that high-level design and low-level design. Only thing is what test team can do is they can test the username password field and submit and cancel these things. Like that, this is a very rigid and least flexible model which is there. So software development during the implementation phase, there are no prototypes happening in this. If any changes happen in the midway, then the test documents along with the required documents has to be changed or updated once again. So this has more resources involved again to change from the top to bottom, as it is sequentially done. So these are the disadvantages in the V model. But as I said, it can also be used in the small and the medium projects where the requirements are fixed and defined. We need to have the technical resource, expertise in the team all the time till the product is developed. So when these things are available, then V-shaped model is suitable and can be used. Going forward, we have incremental model. Incremental model, the whole requirement is divided into various builds. So multiple development life cycles happens here, making the life cycle as multiple waterfall model. If you observe the diagram, the requirements are split into build 1, build 2, build 3, build 4 up to some the desired levels, and each build has design and development phase, testing phase, and implementation phase. So build 1 has these 3 phases, build 2 has again the design, development, testing, and implementation phase. So it's something like each, for example, if you observe down here, the product what we are developing is clear, the picture of Elizabeth, and in the build 1 we are trying to create a small prototype of the face of the Elizabeth and try to showcase to the customer. And second phase, we try to add on to this build for the build 1 and try to showcase the build 2, build 3. If you observe here, so this is like a working software version is produced during the first module. So we have the working software earlier on during the software life cycle. Each subsequent releases of the module adds the function to the previous releases. The process continues and completes the system is achieved. Until all the requirements are met, this kind of build 1 to build n will keep on happening, and each build keeps on adding on the previous builds, and each module there is a testing. So each module has been tested thoroughly and well. So this also has some advantages and disadvantages that we'll be discussing here. The advantages here are generates working software quickly. As you saw small image of the exhibit to see that okay, we can develop. This model is flexible, and if there is any small change, we can adopt. So build 1 or build 2 can be adopted, and this is easier to the testers and debugger to debug where in which build this thing has gone wrong, and we can go back and come back with the same build with a new cycle. So in this model, customer can respond to each model. The customer can give the feedback to the each model that has been built. So this involves lower initial delivery cost and easier to manage the risk, and we can predict how many build cycles are needed going forward. Like build 1, if you start implementing, we can predict that okay, from build 1 to build 10 we can finish this product. So these are the advantages in the incremental model. Requires good planning again here, because requirements need to be broken down, and high level and low level design should be very clear, as only 3 stages are involved in this. Clear and complete definition of the whole system should be done again and broken down and built incrementally. Here the cost is higher because each team needs their own expertise. If you go take implementation, testing, and development, each team, build 1 team should have its own expertise. A build 2 team has its own expertise. So here if the company is able to offer those many kind of expertise, then we can go to have this incremental model approach in developing this kind of softwares. This model can be used when the requirements of the complete systems are clear, defined, and understood. Major requirements must be defined. However, small details can be added or removed. There needs to get a product to the market early. A new technology can be used. A resource with needed skill is not needed at every time. This has some high risk future goals involved in it. Coming to Agile model, which all the software development companies or product development companies are using it. Agile model is also a type of incremental model, but software is developed in incremental as well as faster cycle. This results in a small incremental software releases, with each release building on previous functionality. So each release is thoroughly tested to ensure software quality is maintained. So if you observe the diagram, there is a here what happens is, like, all the things like requirements, high level design, low level design, things happen, but the documentation will not happen here. Like test plans are not written in a very extensive manner. Test specifications are not written in an extensive manner. What happens in the Agile model, what I have experienced is, when you get the requirement from the business analyst, they give to the architect. The architects will split the requirements into smaller stories, and these stories are given to the development teams. Development teams start working on the stories, and they call it as sprints. Sprints, they will take a story which is capable of achieving in 2 to 3 weeks maximum, and in that sprint cycle, the phases will be development, testing, and demo. So each sprint cycle will have one end product. If you observe in the development, same thing, like if you take for example, as I said, contacts, for example, in the phone, what we are trying to develop here, in a contacts, earlier we were able to see add name, contact number, and these things. The contacts is a requirement, and the requirements are again split into stories like add contact. Add contact should have a field with a text, and the text should be not maximum this, should have this many characters, and should not have special characters like this. So once the add contact is developed, next save option, again like that. On the sprint cycle 1, when the demo is completed, sprint cycle 2 starts, and the development teams take the story 2, which is based on the story 1. So it is again adding the functionality above the story 1. So like this, the entire requirements of stories are built in a smaller deployments, and whenever the business analyst or the architect finds that 1 to 5 stories are enough to release to the market, they will release and get the customer feedback very early. And but the development of the other stories will keep on happening. So this is how the Agile model is very useful in the current software development market. Agile model advantages are As I said, the demos are done to the customers in a very faster, in a 2 weeks of cycle. Agile model. The people here interact, like test team and development team are considered as a single entity for a story, and they will interact with each other rather than they follow the process. Like after you do a test coding, I will do a testing. Not like that. Each tester and a developer are of equal capability. So they call it as SDET for tester and software team as software test team members. So here the process or the communication is more transparent, so that the product comes out. So customer, developers and testers will communicate each other. Like as I said, when demo is done, customers will send the feedback. Developers and testers communicate with each other when if there is any issue the unit testing, or if there is any issue while doing a system testing. Each things are communicated at the very early stage, and those things are fixed within the 2 to 3 weeks of cycle in that sprint cycle. So working software is delivered frequently, as I mentioned, in weeks rather than in months. Continuous attention is given to the technical excellency and good design, not to the documentation. Documentation is there, but very minimal. Regular adaptation to changing the circumstances can happen here. Because if any small requirement comes back, we can discard the sprint cycle 1 or sprint cycle 2, and we can add that feature. We are only wasting the sprint cycle of 2 weeks, not the entire 1 month or 2 months of efforts. So this is how we can accept the changes in the agile model and try to deliver the customers requirements at the needed stages. Late changes in requirements are also accepted. So some of the disadvantages here is in some case software deliverables, especially the large ones, it is difficult to assess the effort being required at the beginning of the software lifecycle. If any business person asks how much time do we need to give this, we cannot tell that, because we have broken the entire story into sprint cycles, and we do in agile model. If customer comes back with any new requirement in the middle of the development lifecycle, then we have to integrate those things. So it's a kind of the small deployments that has been done to the markets. There is a lack of emphasis. No necessary design documents have been done. Will be undergone. The project can easily taken off from the track if the customer representative is not clear. If the customer should be clear. If he comes in the middle and says, no, I don't want this requirement, I want the other requirement, but the other requirement should be actually based on the previous story which have been developed. If he comes back and says that no, I want the new requirement, then the entire project goes into the failure mode. So the customer should be very clear with the requirements, and he should, whatever he is trying to give in the middle, any changes, that should also be clear. So the senior program managers are having the authority, taking the sprint stories from sprint 1 to sprint 10 as one product and deploying to the market. So when it is used, customer feedbacks can be implemented. When new changes are needed to be implemented, the freedom of Agile gives the change, as I mentioned, is very important. New changes can be implemented at a very little cost because of the frequency of new increments that are produced. To implement new feature, the developer needs to lose only the work of few days or even only hours to roll back the implementation of it. Unlike waterfall model or agile, in agile model, very limited planning is required to start with the project. Agile assumes that the end users needs every changing in a dynamic business IT world. So this agile model is come up with a concept like dynamic world and dynamic business. So customers are always changing and their needs are always changing. So this is how the agile model is been considered in nowadays. And this methodology is very much used in the software development industry. So there is one more similar to the agile model, that is called as RAD, or it is known as Rapid Application Development Model. This is also an incremental model. In RAD, the components are developed in a parallel manner. It is faster software development process. The phases here, as you see, there is a business model. The information flows in a kind of a waterfall model identified between the various business functions. Data modeling, the information gathered from the business model or broken down is used to define the data objects that are needed for the business. A business model is broken down again into the data modeling. Data models are defined and data modeling are converted to achieve the business information flow to achieve the specification business objectives. And data modeling is processed to high level, low level designs. Automated test tools are developed here to convert the process of models into code to the actual system. Testing and testing of new components and all the interfaces are happening here. So each team has its own business modeling, data modeling, process modeling, application generation, and testing turnover at the every requirement of the businesses. This has advantages and disadvantages. Advantages are reduced to a lot of development time because it's split again. It increases the reusability of the components. If the team one has developed the automation tool, that the tool can be used in the automation of the other team in build too. So like that, the reusability of components keep on happening here, and customer feedbacks are accepted. Integration is started from very beginning to solve the integration problems. Disadvantages are depends on the strong team and the individual performances for identifying the business requirements. So again, the requirement should be very clear, and so we should have a very expertise team here. Only the system that can be modularized, means the system that can be broken down, like object-oriented system that can be broken down into objects or data. In that situation, then RAD is used. It requires highly skilled developers and designers for this kind of model. It is not cheaper. It is very. It will be a costly model if because code is concentrated more on the automation, so that the other team can reuse the components. So that if the things are automated, the application life cycle will be developed faster. So when to use this? RAD is used when there is a need to create a system that can be modularized in 2 to 3 months of time. So in 2 to 3 months of time, project timeline is there, then we can use this RAD model. It should be used if the higher availability of designers for the modeling and the budget is high enough to offer their cost along with the cost of the automated tools to be generated. So it's basically try to simulate the codes. Automation is more emphasized in the RAD model to get the products out in an automated way. So another word in the 2010 now is considered here as DevOps. It's DevOps is nothing but development software team as well as plus IT software team. In my 15 years of experience, I normally what we face is like in Agile model is very good. We use Agile model. See, in Agile model, when we develop a software and try to do the demo, these demos are stored in servers, and these servers needs to be built. Like for example, versions of build version 1, build version 2, like that. So in Agile model, there was a limitation of IT support usage. So to overcome that IT support usage, now the industry has come up with the development plus IT support, that is called as DevOps. So it's a combination of software development, testers, and IT operations. So if you observe, when we develop a entire, for example, if we develop a small component in a mobile, for example, if I developed a contact application which has the user number to store, name to store. For the customer came back with I need to split the name as first name, last name. Okay, we accepted the design in the Agile model. Again, the customer come back, no, I want to save my email ID, my work phone in the same contact. So again, the Agile model worked out. But how to deploy this? See, these models are being developed, but as I mentioned in Agile, contacts has already been deployed in the phone with the name and the number to give an update to the customer over the air, which means if you have observed in the settings, there are about the software. If you click on upgrade, the software gets upgraded. You will get a lot of security patches, any application upgrades, It may be related to anything, contacts, photos, anything like that. The development is happening in the agile mode, but these developments need to be pushed to the customer end. So there we need IT support, so that the product which we have developed in the agile mode goes into the customer end and again get back the feedback. So for that, DevOps is required. So this is how in our company we are using the DevOps. For example, when we develop the application, we include the operational team. We like Jenkins and error manager tools, with all the various tools of testing, where testers or development teams for the product where it helps. We try to integrate these things, and that is not nothing but it is called as DevOps. So DevOps is a set of practice that combines software development and IT operations. It aims to shorten the system development lifecycle, not the story of the lifecycle, product lifecycle, system, entire system. So when it is been in the market, so this means it will provide a continuous delivery with a very high quality software quality. So software agile developers are done, testing is done, but now it has to be deployed. So here the IT people will help us. So DevOps is a complementary, means add on to the agile software development. Several DevOps aspects come from the agile methodology. They also follows the agile methodologies. The word DevOps is nothing but the combination of development and operations. DevOps helps us to increase an organizational speed to deliver the application and services. It allows organizations to serve their customer better and compete strongly in the market. As I said, it's a very dynamic market where end users accepts more of creativity, more of intuition, more of innovation. So this kind of DevOps method is very helpful in nowadays. Why DevOps is needed? Before DevOps, the development and the operation teams worked in a isolation mode. So they never communicated with each other. That testing team and development team were working together with the agile methodologies and other methodologies. But testing and development teams were isolated done after building design. So when they have done their work, then build has been done for a demo has been done, small component. Hence they consume more time to build the actual build cycles, which means that has to be for example, if I come to my mobile phone, we have a lot of builds like debug version, product version, and prototype version. So debug version is normally which is the build which is happening between the testing and the development team, which they will handle. But when it comes to the product build, that time we need IT support. Means we should have the servers where the entire code is built in a very faster manner, and the servers are high capable and high resource, like more RAM and more capability, so they will build faster. So in our laptops we will use only debug model and these things. So that where the DevOps will help, and this kind of DevOps will help us to increase the actual build cycles. Without using DevOps, team members in the sense development and testing may a large amount of time in the testing and development cycle. Nowadays, if you observe Azure or say Amazon Web Server, these things are nothing but DevOps, where the servers are having the high capability to deploy. Like if any person wants to build a code in the Microsoft Visual Studio, uh, it takes 5 to 10 minutes. That is more valuable because every time a fix is happened, developer has to run that code and tester has to test that code. So this 5 to 10 minutes of for each team member is again related to the money and the business effort and resource effort. So that time the Azure model or the AWS servers are come into the picture, or the IT support in the local like heavy servers will help us and give us the build in milliseconds. So in that way, Jiras are used, build servers are used. So this is where design instead of projects. So manual code deployment leads to human errors. So there might be some human errors. We cannot testing team and development team cannot do the product in version of build. It has to be requires a particular skill. So that particular skill is now done by the operations team, and this is a very much need in the operations DevOps engineers. So next, whoever is having this kind of knowledge, DevOps or engineering knowledge, is the demand. It is having a demand. A DevOps engineer is an IT professional who works with the software developers, system operators, and other product with IT staff members to administer the code releases. DevOps have hard as well as soft skills to communicate and collaborate with the development team, the testing team, and operations team. See, DevOps is a kind of managerial person, is a managerial engineer who works and collaborates the work between development, testing, and operations team. So this kind of role is very much needed in the current scenario. So there is a small thing how Agile is helping the DevOps. If you see, Agile breaks down the barriers between the developers and management. But DevOps is about software deployment and operations team. It's entirely about the software deployment where the business is important. Addresses the gap between the customer requirement and the development teams in Agile. But DevOps addresses the gap between the development and the operations team. It more focuses on the functional and non-functional readiness. So it's a testing team and the development team work on this. But DevOps operations and business readiness is concentrated. Agile development permits mainly to the way development is throughout the company. DevOps emphasizes on deploying the software, as I mentioned, over-the-air updates on the mobile, over-the-air updates on your Windows systems. All these are happening because of these servers nowadays, Azure servers or DevOps mechanism. But earlier it was not recognized, but now this from 2010 or 12 onwards, this role has been recognized as Dev operations, development plus operations. So Agile more development puts a huge emphasis on training all the team members to have variety and similar skills and equal skills, so that something goes wrong, all the team members can tackle the issue and give the solution. Development DevOps is like divided and conquer, spreading the skills set between the development and operations team, so that any issues development team can take care, and they continue with a consistent builds. Agile development team manages on sprints. It means that the timetable is very much shorter, like weeks, and several features are to be produced in a lesser period of time. Devs strives for a consolidated deadline and benchmarks with major releases. Like for example, in the mobile industry where I work, we all have the release cycle, software releases cycle, like PR1, PR2, product release 1, product release 2, product release 3, and before this product release, we have the development and testing team that is called as software SSC, that is sales candidate. We are what we call the SC, sales candidate. Once the software development and the testing teams develop this kind of sales candidate, this candidate kind of build is given to the IT operations team to build the product build, which can be given to the customer for the update over the year. So these are called major releases, where the PR1, PR2, that is product release 1, product release 2. So in that release cycle, the DevOps operations are observed. So this is how in the industry Agile and DevOps are working, and currently we are using this kind of methodologies to develop any kind of software in the dynamic IT industry and dynamic customer feedbacks and changes which are happening nowadays. So coming back to the next topic, that is the agenda, software testing techniques. When we have all these methodologies, testing team needs to adopt some kind of techniques, and development teams also need to adopt some kind of techniques to give a better quality of software to the end user. So test design techniques are of two categories. One is static techniques. Static techniques test the software without executing. That's nothing but code walkthrough, or you just a kind of reading the book. Dynamic testing involves in the execution of the software of the component line by line, or it can be a whole system. So again, these things are again splitted. In the next slide, I will show you. So design techniques, if you see static and dynamic. In static techniques, review analysis and static analysis are happening. In review analysis, code walkthrough, technical review, inspection, normal. These are nothing but like is the code. These are also used in the software development life cycle, where we see where the codes are commented properly, where the headers are there, where the every function has its definition. Because when you develop any kind of software code, documentation for the small lines is very much important. Because if you develop a code, if you take any example of the header file, you can observe this header file is used for this, and this has been developed on this, and this is the version. So that is the uh, documentation process in the static method, and that should be there, and that should follow the tab formatting. Like functions should be of capital letters, small letters, and function call should happen within the braces, and that should be tabbed. So these kind of reviews happen in the walkthroughs. So they do not go internally with the execution. So it takes very less time, and this is done within the develop. For example, in Agile, what we do is, when we develop a small function, we share that file to the other team member, asking for the code walkthrough, and send us the comments. So that other team members again shares is like vice versa. So once this is done, that means static review is done within the two developers and testers. When you come to dynamic testing, it is again split into three categories. One is specification based, structure based, experience based. So specification based is nothing but black box testing. The other name, structure based, is nothing but white box testing. Experience based is nothing but, as we have my experience, I can guess the error easily now, where I can get the errors. So when you come to specification based or black box, these things are more widely used. Equivalence partitioning, boundary value analysis, decision tables, state transition testing. When you come to structure based testing, it is statement test coverage, decision test coverage, and linear test coverage. In experience, we have error guessing and exploratory testing. So as I mentioned, the things, these three are mainly taken care by the Agile testing team, or the Agile SDE team, software development tester, who take care of these things. So white box testing is nothing but statement coverage. That is nothing but unit test. We'll for a statement, for example, there is one statement: if A is equal to B, that is a statement in the code, and that statement should be tested, and that statement should be covered by testing team writing a unit test code. And this statement coverage, we will check. There are a lot of static statement coverage tools. When we run our unit test code, which is developed by testing, it will give like which statement is covered, which statement is not covered, like 100% covered, 80% not covered. These kind of things are there. So if A is equal to B is a statement, then that should be covered. Decision is nothing but if A is greater than B. There are two decisions happening. That's a condition coverage. If A is greater than 10, that decision condition coverage is like, we need to test the value for the A. Like if it is less than 10, what happens? If it is greater than 10, what happens? Or if it is equal to 10, what happens? Decision coverage is nothing but true or false. If A is true, B is false. Like Boolean values. So all these coverages, now we have a lot of tools. When we develop the unit testing, we need to develop the unit testing code for this kind, which we run on the development of the header files and the CPP files, which are being developed by the developers. So once we run this tool, it will give us the percentages of coverages: statement coverage, how much percentage; decision coverage, how much percentage; condition coverage, how much percentage. So this coverage, the architect will say statement coverage should be 80%, decision coverage should be 90%, condition coverage should be 70%. When all these coverages are met, then white box testing is successful. So then it goes to next level of testing, that is a black box testing. That is our specification based testing. Where specification is nothing but the requirements. We need to have a text box, and we need to have a save button. These are the specifications. So for that we will be having these 4 techniques that are used, like equivalence partitioning, boundary value analysis, decision tables, and transition tables. I will go one by one. So mainly black box technique is a method or a software testing that examines the functionality of the application. It doesn't go with the internal structure, and the tester as I said, the tester can or cannot have the knowledge, do not have the knowledge of the system or the components, how it is done inside. In black box testing, the tester is concentrated on what software does, like input and output. If I say there is a text, and if I give there is a text, and the tester will say ABCD, and he says save, then it should be saved. That's a valid input. And for the negative inputs, again he has to test. So again, those things are splitted. The definition of these black box techniques are again splitted into functional and non-functional testings. Functional testing is concerned with examining the system. Does this feature consist or the functions? Non-functional testing is concerned with the examining how well the system does. Non-functional testings are like performance testing, usability testing, probability testing, maintenance testing, load testing, stress testing. Lot of things are there in non-functional testing. It can be chosen based on the project goal, project aim. If you develop any TCP IP kind of project, then we have to go for the load testing, stress testing, and this kind of testing. If you are developing any UI related testing, then usability testing, portability testing, performance testing is needed, and maintainability testing is needed. And if it is a application, then we need to go for localized testing where all the languages are supported. So a lot of non-functional testings are available, but it depends on the application or the product, as I mentioned. The specification based testing or nothing but black box testing are appropriate at all levels of testing. Means this kind of techniques can be applied at the any kind of testing life cycle, and where the specification exists. For example, when you are performing system or acceptance testing, the requirement specification or functional testing may form the basis of the test. The specification based testing is also known as black box testing. There is, as I mentioned, input or output driven testing, or it is also called as, because they view the software as a black box testing with inputs. There are 4 specification based testing: black box testing, equivalence partition, boundary value analysis, and decision. So in simple, equivalence partition is nothing but breaking down. Equivalence partition is specification based testing or black box based technique. It is applied at all the levels of testings, and often it's a very good technique to use. In general, if there is an input of a certain range which are valid, and other ranges which are invalid. Invalid data here does not mean that the data is incorrect. It means that this data lies outside the specification of the partition. For example, if you see the figure, there is 1 to 12. For example, if you are developing a calendar, we know that it has got a value of 1 to 12 months. So this is the valid partition for us to test. So when we consider this as a valid partition, equivalence partition says that we need to have invalid partitions at the other ends. So invalid partitions happen between the minimal value of the valid portion and the minimal value of the invalid portion at the other end. And the other side of the invalid portion will happen the maximum at the valid portion and the maximum at the invalid. If you observe, what happens, for example, if I give 0 for the application that has been developed for the calendar, either it will crash or it will say this is not accepted. So that kind of testing is needed. But here we need to understand one thing. In this range, if you select only if I in the valid partition say 1 to 12, if I say select 6 as input, If it works fine, then no need to test all the 12 things like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 12. So this reduces the effort of the tester. So this is how valid partition helps in developing the test case, and it also helps in identifying the invalid partitioning, how it behaves when if other invalid inputs are given. So this is how the equivalence partitioning is helpful. So the testing theory is related to the equivalence says that only one test case of each portion, for example, as I mentioned, 6 or 8 is more than enough to test in this valid partition. And here -2 or say -1 is more than enough to check for the invalid partitioning. And this is nothing but the equivalence partitioning, and for that the test cases will be developed by the tester, and these things will be tested. So if he is an invalid or inexperienced tester, he will attempt to test all the values from 1 to 12, and he might forget to give the invalid partitioning. So this leads to a problem. So this is a very good technique that is used in the software testing techniques nowadays. And boundary value analysis. In the same example, as I said, in the valid, what happens? I took the example of 6 and 8. But in boundary values, we forgot to develop the test case for 1 and 0. What happens if 1 and next to that 0 is given to that? What happens if 12 and 13, the value is given to that? We know that this is even though it is valid, but we tested only with the higher values like 15 or -2, or in the middle values or the valid portion of 6 and 8. So these boundary value conditions are very important. If you take an example, when a heater is turned on, if the temperature is 10 degrees or colder, there are two partitions. For example, temperature is less than or equal to 10 degrees, temperature is greater than 10 degrees. Now the two boundary values to be tested here is temperature is equal to 10, what happens? If the temperature is at 11, what happens? So these boundary values again makes two test cases are called as boundary value test cases, which is used where boundary values falls within the invalid portion of the test cases design. So to ensure the software components handle the value in a controlled manner, the boundary value analysis can be used throughout the testing life cycle and is equally applicable to all the testing phases. So boundary value analysis and equivalence partitioning analysis is very helpful to find the issues at the very early stage, and it makes us consume the less time. Coming to the decision table, as you all know, decision table is nothing but you have to take a decision. For example, if the printer, for here I have taken when printer conditions, printer what it has to do, it has to print. So what we need to check here before printing, we need to check whether the power cable is connected. Okay, you need to mark that. Okay, ensure the printer software is installed on your laptop machine. You need to make the decision is installed. So when all these action points are okay, passed, then the paper is printed. So this is nothing but the action of printing is based on the action of the inputs. So when all the inputs are okay, then the printer is working fine. So this is how the decision tables are developed. Or this is mainly used in the programming language where if else or switch cases statements are more here. When you come to state transition testing is used where some aspects of the systems can be described. It is called as finite state machine. That is, you might have observed like FAFL. This simple means that the systems can be finite number of different states, and the transition from one state to another are determined by the rules of the machine. This model on which the systems can be tested or based. For example, if you have a credit card, when you insert the credit card, what it asks? It should ask for the pin, or it should wait for the pin. When the pin for the first try, the pin is successful, then it will go into the access. Pin is not okay, it will go for the second try. Please enter once again. Second try is okay, then access. Else fail third. Or if third has also failed, then the card is disabled. So like that, this is the states of the function that is moved one by one. So for these states, we will be developing the test cases based on the state of the machine. This kind of thing is used very in the graphical applications, where the flow of machines, websites. If you click on this, it should go to next. If you click on that, it should come to back. If you click on this, it should go to next. Forward. When you click on home, what should happen? So this kind of state transition kind of testing design is used in the web page case of development or UI development testing, basically. So last and finally, error guessing. In the software testing, error guessing is a method in which test cases are used to find the bugs based on the history. As I mentioned, we have developed one phone, and that phone is similar to the phone which is coming into the market. So the phone which is coming into the market, I know what are the critical issues that have been found in the previous phone. I try to run those scenarios in the phone that is being under the development phase. So this is nothing but we are guessing the error. That error might happen in this. So checking that. So this kind of method will happen only based on the experience on the prior testing. So when you are tested some say 10 UI some 5 to 6 websites, we will come to know that okay, if I click on home button, it should go to home page. Or what if I click on cancel? Whether it should stop in the same page or it should go to keep on refreshing the same page. If I click on both the refresh and stop, what happens? So these kind of parameters have been tested by the experience, and this kind of testing will happen when you are developing a new software on top of that. So it is nothing but sixth sense, or you can call it as an intuition to determine what situation that cause mainly the software failure that has been appeared in the previous things. Typically, the errors, as you know, giving the invalid parameters like boundary value conditions, divide by 0, passing the null parameters to the functions. So these things are nothing but error guessings. The error guessings has no explicit role for testing. The test cases can be designed depending on the situation. There is no drawing for normal documentation like error guessing should be documented. So there is no hard and fast rule like the steps should be followed for error guessing. So that's all from my side. And if you have any questions related to thing, let me know. And thanks for all for listening to.
Thank you, Mr. Chandrasekhar BS. We'll go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the YouTube chatting box.
So will you will be sharing the question to me, Lakshmikant?
Yeah, I'll tell you one by one.
Okay.
Sir, here we have a question from Chandrama, Associate Professor VKIT. Which method of testing is more accurate?
Test which method or say again, it depends on the project what you are developing. Say for example, in your college project, if you are developing a search engine, then you have to go with the agile model, because search engine cannot be developed at the limited time space like 2 to 3 months. So it's a continuous development for a Google. If you are developing a Google kind of search engine, then you have to use agile methodology with boundary value conditions and the state transition techniques. If it is the same thing happening to the small projects, if the requirements are clear and you are done, for example, a salary payroll, where the list of employees are identified, grades are identified. For the grades, the salaries are identified. Then you can go with the V model, where the requirements are clear and everything is clear. Then you can have the boundary value condition, whether the salaries go beyond the range, or if the more employees are added, what happens. So that way you can decide on the methods and techniques.
Sir, we have one more question from the same candidate. When we will use manual testing?
Manual testing, see, in the current scenario of agile methodology, manual testing happens when the story is taken. For example, as I said, the requirements are broken down into stories, and once developer starts developing the functionality, then the tester starts developing the unit test code. When that small function, for example, if you say there is a website which accepts login, username, and password, then manual test team can take over when there is a full-fledged of text box of login, username, password, text box, and save text box. Then the manual testing team can take part in that.
Sir, we have one more question from Hemant Kumar. For any given application, what are the different types of testing carried out?
For any given, for any given kind of application, types of testing is like depends. Like as I mentioned, if there is a application related to TCP/IP network related stuff, if you are developing a router, for example, you are working for a Huawei company, and that company is developing a router software to manage the load. How many people are connected at a time, and if there is a load, how to distribute the load between the nodes. And in that way, the load testing, stress testing is useful. If you are developing a small UI related, for example, mobile phone application, you only develop this mobile phone application for your own kit. That time, the UI related stuff, like when you click on the icon, what happens? The state is changed from one state to other state. When you click on that icon, what action is happening? So there the state transition techniques is used, and the UI related stuffs are used. So it depends on the application's life cycle or the application that have been developed.
Sir, we have one more question from Sunanda HG. What type of projects can student do based on DevOps?
See, based on DevOps, a lot of projects can be done. To be frank, to be a tester, it's a great value to me. For example, DevOps now you see Azure and AWS are there, the web servers, and if for example for your college only, for a new admission, guys are coming. You can take the feedback of the candidate. How the online exams happened. Are you satisfied with the online exams questions? Are you satisfied with the questions? Are you satisfied with the number of questions that you had? If you develop this kind of application, that feedback will come back to you. That feedback can be stored. For that, to develop this kind of application, then you know the DevOps. That means IT servers, IT people help is needed, because when online application means you see that a lot of people are getting registered and a lot of people try to access the thing at the same time. So this small application can be developed for your college online. Online examination, when you develop how the system of your IT servers behave, or when you combine both the things, like IT team and development team, how the website behaves, whether it crashes or whether it keeps in the same mode. Like that, DevOps can be used in your college projects.
So actually, we have one more question from Cjo J. How to test my project?
See, that's what testing is nothing but it doesn't require any knowledge. See, if you give to kid, for example, I say tester should be free of mind. Tester should be creative and should be having the ability to break the system. See, this is the main thing. The tester should have a mindset to break the system in any condition. Like for example, radio nowadays, you are playing a radio in the mobile phones. If you listen to FM radio in a loudspeaker and you get a call, that is an interaction testing. What happens? That means whether radio is paused and you are able to hear the call, or when you are hearing a call, is the radio music listened in the background of your call? Or when you remove the headset, when nowadays the phone comes with the headset, then only radio is getting on. So when the headset is removed and pushed 10 to 100 times inside the socket, what happens? Does it crash or does it stop working? So it is nothing but testers should have the mindset of breaking the things and should be always thinking in a different out of box thinking rather than developing the things. So what testers mainly I see as testers should have creativity, or innovators, or should have out of box thinking, or you should be able to break the things. So what these things, these kind of mindset leads to a tester is come up with the innovation. Innovation is nothing but creating a new thing. As I mentioned, I in my 15 years of experience, I have given a lot of ideas to the project teams. In that project teams, the customers were happy, and they try to implement one or two features of mine, and I got the appreciations. So these things will happen. So when you say, see now people are very innovative and try to make easy use of it. For example, if you are having a touch phone, if you have touch phone, the people are thinking of touching the phone, and they need to connect with a single click. But user has to do the 2 clicks. How will you do that? So these things will make you do the creative things or try to break the things. So this leads the innovation of the product, or new stuff will come within you, and things will happen.
Thank you, sir. I have last question. How RAD is different from other models? V model, waterfall model testing.
See, RAD is again a sequential model, but it mainly emphasizes on the automation part. Like it tries to like build a team 1, team 2, team 3. It's been splitted. The team 1, when it is built some component, it's try to utilize the same component and automate the other things of the next components. So it tries to make the software life cycle faster. So that RAD cycle involves specific expertise like automation team. We need to know the automation team guy need to have the framework knowledge. What is framework? How to develop a framework? And if the framework is developed on all operating system or all websites or portability, these things are needed. So it's a kind of costly project, but automation is more emphasized on that in the RAD.
Thank you, audience. Hope we have answered all the questions. Thank you, Mr. Chandrasekhar BS, for spending your valuable time with us in your busy schedule. Thank you very much.
Okay, thanks for all the participants, and thanks for my
Vidya ma'am.
Yes. Thank you, sir, for sparing your valuable time and sharing your knowledge with all the participants. So thank you so much. Dear participants, tomorrow's session will start at 6 p.m. and even Sunday it starts from 6 p.m. So tomorrow we have with us Mr. Vinod Kumar, who is the alumni of our college itself. So we are proud about that. So please do attend all the sessions. Thank you.
Thanks again for joining us today, and we will see you tomorrow at 6 p.m. Thank you all.
Okay.
Thank you.
Thank you, Chandrasekhar.
Bye-bye.